Sir, you can start now, sir.
Yes, ma'am. So last class we were learning about SN1 and SN2 mechanisms. In detail we learned, yes, Ajay?
Yes, sir.
Yeah, we learned some of the questions also. Almost all the questions we have done in that concept. Few more questions, 2 or 3 questions, and then we'll continue with the next part of the topic. Now, 2-chloro 2-methyl propane. Now, what is this 2-chloro 2-methyl propane? Now, propane, I will write like this. 3 carbon atoms, propane, I will write. 2-chloro, this is 1, 2, and 3. 2-chloro, this is chlorine. And at second position, you have another methyl group, it is CH3. This is nothing but tertiary butyl chloride. This is tertiary butyl chloride. Now, when this tertiary butyl chloride is allowed to react with alcoholic KOH. What do you mean by alcoholic KOH? Now, this alcoholic KOH means potassium hydroxide. Potassium hydroxide dissolved in alcohol. Dissolved in alcohol is called as alcoholic potassium hydroxide. This alcoholic potassium hydroxide is a dehydrohalogenating agent. It's a dehydrohalogenating agent. What do you mean by dehydrohalogenation? Removal of halogen and hydrogen simultaneously. Removal of hydrogen and halogen simultaneously from the adjacent carbon atom. From the adjacent carbon atoms. That means hydrogen and halogen will be eliminated from the neighboring carbon atom, adjacent carbon atom. Now, what you're supposed to understand in this question is, this carbon is a tertiary carbon atom. Why? Because this carbon is bonded to 3 other carbon atoms. Therefore, it's a tertiary carbon atom. This carbon is bonded to only 1 carbon atom. This is a primary carbon. This carbon atom is bonded to 1 carbon atom. This is also primary. This carbon atom is also bonded to 1 carbon atom, primary. So these 3 are primary carbon atoms. That means all these 9 hydrogen atoms will behave like what? Same. When we say not all these 9 hydrogen atoms will behave same, you can show the reaction taking place at any of these carbon atoms. We can show the reaction taking place at any of the carbon atom. When we say that we can show the reaction taking place at any of the carbon atom, for our understanding, this CH3, I will write like this. CH2 and H, I will write. For understanding, I'll write CH2 and H. Now, what happens is K and Cl gets eliminated as KCl. In place of, no, not place, this hydrogen and this OH gets eliminated as water. Now, what happens? Now, you have CH2, single bond C, CH3, CH3, and what? This carbon is not stable. This carbon atom has only 3 bonds, and this carbon atom also 3 bonds, 2 with an hydrogen and 1 with carbon. Since we have eliminated 1 hydrogen from this carbon atom and 1 chlorine from this carbon atom, a double bond will be formed between these 2. When double bond is formed between these 2, what will be the name of this molecule? The name of this molecule will be 1, 2, and 3. 3 carbon atom, therefore it will be called as for prop, and since we have a double bond, propene. At second position, we have methyl group, therefore it will be called as methyl propene. So what methyl propene? 2-methyl propene or 1-ene. Prop 1-ene or 1-propene, because the double bond is at first carbon atom. Hence, the answer for this question is option C. Did you follow this?
Yes, sir.
The next question, the ease of dehydrohalogenation. The ease of dehydrohalogenation of alkyl halide with alcoholic potash will be in the order. Tertiary is easier. compared to secondary. Secondary is easier compared to primary. So dehydrohalogenation also will be easily undergone by tertiary alkyl halides compared to the secondary and primary. This sequence you should know. Dehydrohalogenation. Next, elimination of bromine from 2-bromobutane. Elimination of bromine from 2-bromobutane results in the formation of 2-bromobutane. First, butane, we will write 4 carbon atoms. 2-bromo, maybe I'll write to second position, I'll write bromine. Now you balance the hydrogen. I have CH3 here, I have H here, I have H here, I have H here, I have CH3 here. Like this, I will write CH3. Here also, I will write CH3 in that fashion. I will write here H. Here also we have H. And this is H. This is nothing but 2-bromobutane. Elimination of bromine from 2-bromobutane results in elimination of bromine cannot be happening alone. So the reagent what we use is alcoholic potash. When we use alcoholic potash, this K and Br gets eliminated as KBr. Now see the possibility. Now I will say this hydrogen gets eliminated along with this OH as water. All right, this is the first possibility. I'm telling you the second possibility. Instead of this hydrogen, one of these hydrogen, because this is also neighboring. So one of this hydrogen can eliminate instead of this. Now, before we talk about this, we will talk about the product formed here. The product formed here. What's the product you will get? The product you will get is you have CH3, you have CH, you have CH, double bond will be formed here, CH, and you have CH3. This is 2-butene. This is 2-butene. In the second case, we will understand this. In the second case, this hydrogen, instead of this hydrogen, one of this hydrogen gets eliminated. So what will be formed now? What will be formed? Instead of this in the second case, this hydrogen gets. So what will I get? I'll get CH2. I will have a double bond here, CH. And this CH2 will remain in the second case, CH2 and CH3. This is 1-butene. Now 1-butene formed is 20% and 2-butene formed is 80%. All right, because of something called as Zaitsev rule. Zaitsev's rule. ZAI, Zaitsev, SCV, ZAIT, SCV, Zaitsev's rule. It's a Russian scientist. He's a Russian scientist. The answer for this question will be what? Elimination of 2-bromine from 2-bromo results in the formation of, see, 2 products are formed. One is 2-butene, the other one is 1-butene. 80% of 2-butene, it's based on Zaitsev's rule. Highly substituted alkene will be preferred as the product. Here, highly substituted means second carbon atom, you have a double bond. Here you can see the first carbon atom itself is a double bond. So this is highly substituted. So therefore, the product formed will be predominantly 2-butene. Hence, answer for this question will be option B. The last question, and then we'll continue with the next part of the topic. The order of reactivity of methyl halides in the formation of Grignard reagent. Methyl halides in the formation of Grignard reagent. Now, Grignard reagent is formed when alkyl halide is heated with magnesium in dry ether. When alkyl halide is heated with magnesium in dry ether, what happens is magnesium gets bonded between R and Mg. Therefore, you get RMgX. This RMgX is the general representation of Grignard reagent. Now, you should remember, we have alkyl chloride, we have alkyl bromide, methyl bromide, and you have methyl iodide. They have given 3 components here. Now, you should remember, chlorine is smaller compared to bromine, and bromine is smaller compared to iodine. So, chlorine is smaller compared to bromine, and bromine is smaller compared to iodine. Now, as the size of the element, ions increases, see the alkyl groups are same in all the 3, but halogen size, iodine is larger. When iodine is larger, the bond between carbon and iodine becomes longer. When the bond becomes longer between carbon and iodine, to break the bond between carbon and iodine becomes much easier compared to carbon and bromine and carbon and chlorine. So if this bond can be broken easily, it means this CH3I will be more reactive than CH3Br, and that will be more reactive than CH3I. So the reactivity will be CH3I is greater than CH3Br, and that will be greater than CH3Cl. So you should remember, as you go down the halogen family, the bond length increases because of the size of halogen increases. Therefore, what happens is the reactivity also increases. Hence, the answer for this question will be option A. Did you follow these concepts, what I'm talking about?
Yes, sir.
Yeah. The next concept we will learn, preparation of dihalides. How do you prepare dihalides? Dihalides, now we were talking about something called as monohalides. So far, we were talking about monohalides. Now, how do we prepare dihalides? Very less weightage is given for the preparation of dihalides in your syllabus. Anyways, we will learn. The first method is from geminal dihalide. What do you mean by geminal dihalide? Methods of preparation of geminal dihalide. Preparation of geminal dihalide. Now, dihalides means two halogens. If a carbon contains both the halogen atoms, then it is called as geminal dihalide. So if both the halogens are present on the same carbon atom, it is called as geminal dihalide. Next is vicinal dihalide. Vicinal dihalide means if you have two carbon atoms, if the carbon atoms are halogen atoms are adjacent to both the carbon atoms, then we call it as vicinal. VICINAL, vicinal dihalide. If we take few carbon atoms like this, and if halogens are present in the first and the last carbon atom, then it is called as terminal dihalide. Then it's called as what? Terminal dihalides. Dihalides means two halogens. All right. If both halogens are present on the same carbon atom, it's called as geminal dihalide. If halogens are present on the neighboring carbon atom, it's called as vicinal dihalide. If halogens are present at the first and the last carbon atom, it's called as terminal dihalide. Now we are talking about the preparation of geminal dihalide. How geminal dihalides can be prepared. Now geminal dihalides can be prepared from the following reaction. That is, first one is from alkynes. From alkynes. C triple bond CH. Now we will take a specific example. 1 propine. We'll take 1 propine. This is 1 propine. See, 1, 2, 3 carbon atom. So therefore, root word is prop, carbon to carbon triple bond you have. Therefore, they must end with YNE, propine. This propine, when it's allowed to react with hydrogen bromide, assume that we're talking about allowed to react with hydrogen bromide. Now, when hydrogen, see, you know Markovnikov's rule. Whenever a hydrogen halide is added to an unsymmetrical alkene, we learned. Here it's again alkyne. Alkene and alkyne, any unsaturated molecule. The negative part of the added molecule gets bonded to the carbon containing less number of hydrogen. So bromine will attack this carbon and hydrogen will attack this carbon. Therefore, the first intermediate product what we get is, we will get CH3Br. A pi bond will break here. Therefore, double bond will be there, CH and H. When this is further reacted with hydrogen bromide, again, the negative part of the added molecule gets bonded to the carbon containing less number of hydrogen. So what is that you get? You get CH3, CBr. Here also you get Br. You have single bond now, H, H, and H. See, both the bromine atoms are present on the same carbon atom. Therefore, this will be called as a geminal dihalide. What will be the IUPAC name for this geminal dihalide? I will write like this: CH3, Br, CBr, and CH3. What will be the IUPAC name for this molecule? 3 carbon atom. Root word will be prop, and carbon to carbon single bond propane. 2, 2 dibromo. 2,2 dibromopropane. So this is an example for geminal dihalide. They have given you a general representation here. The next one is from carbonyl compounds. Now, from carbonyl compounds here, aldehyde is taken as a carbonyl compound. Ketone is also a representation of carbonyl compound, but yes, example, they've taken an aldehyde. Now, acetaldehyde, if we take CH3, CH double bond O, if we take acetaldehyde, and if this is allowed to react with phosphorus pentachloride, heated with phosphorus pentachloride. Now, I will write phosphorus pentachloride as Cl2 and PCl3. So what happens is, this place of O, Cl2 comes, and this oxygen gets reacted with PoCl3. Therefore, what do I have now? CH3, CH, Cl2, and you will have PoCl3, phosphoryl chloride. So this is an example for a terminal dihalide they mentioned, but it is also a geminal dihalide, because you can see the structure. If I write CH3, I can write the structure like this, Cl and Cl. Both the halogens are present on the same carbon atom. Therefore, it will be also called as a geminal dihalide. It's not called as terminal dihalide. Present on the same carbon atom. It's wrongly printed. It is geminal dihalide. Ketone is taken, internal dihalides are formed. If ketone is taken, internal dihalides, meaning if I have a molecule like the CH3, C double bond O, CH3. If this is heated with PCl5, now PCl5, I can write it as Cl2 and PCl3. This PCl3 and oxygen gets eliminated as PoCl3. And what's that you get? In place of this oxygen, you will get Cl. So you will get CH3, CCl, Cl, and CH3. This is also called as a geminal dihalide, but they're calling it as internal geminal dihalides. And here, maybe this name can be given as a terminal dihalide because it is in the extreme last carbon atom. Therefore, it also can be called as a terminal dihalide. Followed? Who's there?
Yes, sir. Yes, sir.
Yes.
Followed, sir.
Next is methods of preparation of vicinal dihalide. I clearly told you what is vicinal dihalide. Dihalides, halogens which are present on the neighboring carbon atom will be called as vicinal dihalide. Now we will take a simple example again. We'll take a propene. We will take propene, and this propene, when you chlorinate, one chlorine attacks this carbon, the other chlorine attacks this carbon. So you get CH3, CHCl, single bond, CH2, CH2, and you will get Cl. CH2 and Cl. So this is halogens are present in the neighboring carbon atom. Therefore, it will be an example for vicinal dihalide. Now again, it is from vicinal glycol. Vicinal glycol. Ethylene glycol, you can take as an example. So they've taken a higher glycol here. Instead of H, they've taken an R here. So this glycol, when it's is replaced by Cl. When these are replaced by Cl, you get vicinal dihalide. The byproducts are 2HCl and phosphoryl chloride. The properties of dihalide. What are the physical properties of dihalides? Dihalides are colorless with a pleasant smell, and it is insoluble in water, soluble in organic solvents. So dihalides are insoluble in water and they're soluble in organic solvents. And you can see there, this is a general trend in the periodic table, general trend, that is, as the molecular mass increases, melting point and boiling point increases. Remember, melting point and boiling point increases. The next one, this is also a note we should remember, that is, vicinal dihalides are more reactive than geminal dihalides. Vicinal dihalides are more reactive than chemical properties. We will learn chemical properties. Similarly, for the reactions will be same as we learned it for monohalides, alkyl halides. Now this is for dihalides. So what's this dihalides? Now We will take an example. Now, they've given RCHX2. We will take CH3, C. We'll take bromine as a halogen here, and also we will take H. This is a dihalide. It's a geminal dihalide. When this is allowed to react with aqueous potassium hydroxide, not aqueous, aqueous potassium hydroxide. It is not alcoholic potassium hydroxide, it is aqueous. See, alcoholic potassium hydroxide will undergo dehydrohalogenation. Aqueous potassium hydroxide will undergo nucleophilic substitution reaction. Remember the difference. Now, this 2K and this 2 bromine will get eliminated as 2 KBr. In place of these 2 bromine, 2 OH group goes. When I say 2 OH groups goes, you get CH3. I can write C. In place of this, you write OH. I will rearrange. I will write this as H. I will write here OH, rearrange the term, okay? And here also I write OH. Now, if a carbon contains 2 OH groups, it will be highly unstable. It will be highly unstable. When I say it will be highly unstable, what happens is there will be a loss in water molecule. So water H2, this oxygen will be there, H2. When water molecule gets eliminated, what is left out? You have CH3, CH, and there's an oxygen here. A double bond will be formed. Aldehydes will be formed. So when geminal dihalides are treated with aqueous potassium hydroxide, you get an alcohol. Intermediate compound is an alcohol, no doubt. But since carbon contains 2 OH group, the water molecule gets eliminated because these are bulky groups. Stability of this molecule will be less. Therefore, water molecule will be lost to form an aldehyde. Did you follow this reaction? General reaction is given here. Followed? Nobody's talking to me.
Yes, sir. Followed.
Yes,
Yeah.
sir.
Next, reaction with alcoholic potassium hydroxide. Now, alcoholic potassium hydroxide. Now, dehydrohalogenation, we will write an example here. The example is maybe we'll take CH3, CHB. This is a vicinal dihalide, geminal dihalide they've given here. Maybe we'll write, 1 minute. We will take the same example and write geminal dihalide. We'll take R as CH3. You have CH2 and you have CH, and here it is bromine and here it is bromine. Now, when this is allowed to react with alcoholic KOH, dehydrohalogenation has to take place. What is the dehydrohalogenation? Now, one halogen and this hydrogen, because from the same carbon atom, hydrogen cannot be removed. When they get eliminated, what you get? You get CH3. This CH will be there. You have a single bond here. You have CH and you have Br. You have Br. But what happens? Since bromine and hydrogen is eliminated, there will be a double bond formed here. So what will be the name of this molecule? The name of this molecule is 1-bromo, 1-propene. 1-propene. Alkenes are formed. This alkenes, when you heat it with strong dehydrohalogenating agent. See, alcoholic potassium hydroxide is a dehydrohalogenating agent, no doubt about it. But the stronger dehydrohalogenating agent is soda amide. Hydrogen also gets eliminated. So what you will get here, you have a double bond, you have CH. But what happens since bromine and hydrogen are eliminated, the product formed will be 1-propyne. So it will be 1-propyne. So similarly here also, it is 1-propyne. And here two vicinal dihalides. So vicinal dihalides, directly when you react with KOH, you get alkyne. So no need to use what? Soda amide. So alcoholic KOH is enough to bring dehydrohalogenation in case of vicinal dihalide. The next reaction, reaction with zinc dust. Geminal dihalides form higher symmetrical alkene, vicinal dihalide form respective alkene. So what is that? Geminal dihalide forms higher symmetrical alkene. Now, for an example, if you take a geminal dihalide, CH3, C, Cl, and Cl, and CH3, if you take, right, and this is heated with a zinc dust, what happens? Zinc dust, higher symmetrical alkene is formed. So chlorine gets eliminated. No, this is not going to happen. I don't know why an alkene is formed here. No, this is, I'm not convinced with this statement, because if at all zinc chloride also gets eliminated, so you will have CH3, you will have C, and you will have what? CH3. So double bond, where it's going to happen? It's not going to happen anywhere, because both halogens are eliminated from the same carbon atom. So anyway, this is not convincing for me. But vicinal dihalide will respectively give an alkene. That's for sure. I'll come back to this the next class. The reaction of zinc dust with vicinal and geminal dihalide. I'll come back next class. Now, next is reaction with KCl. Reaction of dihalides with KCl. Dihalides, general representation there's given. We will take CH and bromine. This is a geminal dihalide. When it's heated with potassium cyanide, what happens is this 2K and Br gets eliminated. In place of this Br, one cyanide attacks this carbon and this otherwise. So this is called as nucleophilic substitution reaction. You get CH3, C, Cn, and you have Cn and hydrogen. This on hydrolysis. This when you hydrolyze in the presence of an acid, what happens is, now I will write this reaction here. Please try to understand. Because of lack of space, I write like this, Cn. Happens is the bond between carbon and nitrogen breaks. Water, I can write OH, O and H2. Second mole of water, I can write it as OH and H. See, byproduct is ammonia. Here also carbon and nitrogen breaks. Water, I can write it as O and H2. The second water molecule will represent as OH and H. So what happens? How many moles of ammonia gets eliminated? 2 moles of ammonia gets eliminated. In place of this nitrogen, what goes? Carbon. So I'll get CH3, C, hydrogen, I get COOH, and I get COH. Dicarboxylic acid I get. Did you understand? So whenever a dihalide is allowed to react with aqueous potassium cyanide, followed by hydrolysis, dicarboxylic acids are formed. Dicarboxylic acids are formed. Follow with this?
Yes, sir.
Students are, yeah.
Yes, sir.
Next is other substitution reactions. Now it's a dihalides. These all are dihalides. When this dihalide has H and NH2. So what happens? H and X get eliminated. Here also H and NH2. H and X gets eliminated as HX. In place of X, what goes? NH2. Therefore, you get CH2NH2, CH2, NH2, ethylene diamine. We've been learning this in coordination compounds. Now, similarly, the next reaction, when dihalides are heated with sodium acetate. The sodium acetate I can write like this, CH3CONA. Likewise, I can write CCH3. So what happened? Na and X gets eliminated as NaX. Here also Na and X gets eliminated as NaX. So what gets bonded? Carbon. Here also carbon gets bonded. You can see oxygen gets bonded. Sorry. So CH2O, CO, CH3, CH2O, CO, CH3. All right. This is an addition product. Now trihalides. Trihalides, these all are there in your syllabus. Trihalides, example for trihalides are chloroform and iodoform. Iodoform is CHI3. This iodoform is a pale yellow solid. Pale yellow solid, and chloroform is a liquid, remember. Now chloroform, the IUPAC name for chloroform is trichloromethane. The IUPAC name of chloroform is trichloromethane. It's an important trihalogen derivative of methane. It was discovered by Liebig in 1831, and it's named the name chloroform was proposed by Dumas as formic acid on hydrolysis. So chloroform on hydrolysis gives formic acid. Therefore, it was named as chloroform by Dumas. In the past, it was extensively used as anesthetic for surgery. In the past, in the beginning of the science, okay, chloroform was used as an anesthetic for surgery, but now it is rarely used because it causes liver damage. Since it causes liver damage, chloroform is rarely used, but it's an anesthesia, right? Preparation of chloroform. How can we prepare chloroform? Chloroform is prepared both in the laboratory and on large scale by distillation of ethyl alcohol or acetone with a bleaching powder and water. The yield is about 40%. The available chlorine for bleaching powder serves both as oxidizing as well as chlorinating agent. See, bleaching powder chemical formula is actually CaOCl twice dot CaCl2 and it is H2O. This is the actual combination of bleaching powder. This is the actual combination of bleaching powder, but the active part in the bleaching powder is CaOCl2. This bleaching powder, when it's allowed to react with moisture or water, you get calcium or hydroxide liberating chlorine gas. This chlorine gas is behaving like an oxidizing agent as well as chlorinating. Bleaching powder itself acts as an oxidizing agent and chlorinating agent. Chlorinating agent means which gives chlorine for the reaction. That's to be called as chlorinating agent. Now, how do you prepare chloroform from alcohol? Now, chlorine reacts with water to form HCl. You can see here, these two H and Cl2 gets eliminated as HCl and nascent oxygen is given. Since nascent oxygen is given, this is a good oxidizing agent. Chlorine is a good oxidizing agent. So when it's treated with an alcohol, ethanol, what happens? Alcohols are oxidized to aldehydes. Now, alcohol, we write CH3, CH2, OH. When this is oxidized, what happens is these two hydrogen and oxygen gets eliminated as water. And what's the product you get? You get CH3, you have CH, and you have a double bond O. This is nothing but aldehyde. The byproduct is water. This aldehyde which is formed further reacts with chlorine. So these three hydrogen atoms are replaced by chlorine. So what you Cl3 and you have what? CHO. This is called as trichloroacetaldehyde. Trichloroacetaldehyde. Acetaldehyde, or it is commonly called as formed is hydrolyzed by calcium hydroxide. This is chloral. This is trichloroacid. This reaction. Students, are you there?
Yes, sir.
Yeah. Ajay, are you there?
Yes, sir.
Yeah. The reaction they have shown, trichloroacetaldehyde with calcium hydroxide. See, CCl3CHO is trichloroacetaldehyde. CCl3CHO is trichloroacetaldehyde, chloral. When this is treated with calcium hydroxide, you can see what is that? You get CHCl3, that is chloroform. You get CHCl3, again the second mole of chloroform. What else you have? Calcium acetate. You get calcium formate. You get calcium formate. CaHCOO twice. So calcium formate. So how can you prepare chloroform? We can prepare chloroform by the reaction of chlorine on ethanol. So when chlorine is reacted with ethanol, the final product you get chloral. This chloral is hydrolyzed by calcium hydroxide to form chloroform. This is one of the method of preparing chloroform. The second one is from acetone. Acetone is CH3COCH3. When this acetone is chlorinated, you can show this is a symmetric molecule, simple ketone. Any of the hydrogen you can show. So they're shown here, these three hydrogens replaced by chlorine. So you get trichloroacetone. This trichloroacetone, CH3CO, CCl3, and you can see CCl3, COCH3. This trichloroacetone is allowed to react with calcium hydroxide. So what takes place? Hydrolysis. CHCl3, CHCl3 chloroform is formed, and you will get calcium acetate, CH3COO, CH3COO, calcium acetate. So the byproduct is calcium acetate and chloroform. So you can prepare directly from aldehyde and ketone, just reacting aldehydes and ketones with chlorine followed by hydrolysis of the byproduct with calcium hydroxide. The second method of preparation is from carbon tetrachloride. Carbon tetrachloride, nowadays, chloroform is obtained on large scale by reduction of carbon tetrachloride with ion filings. So carbon tetrachloride, when reduction is reaction with hydrogen. So what happens? CCl4, one hydrogen and one chlorine gets eliminated as HCl. Now we can write like this: CCl3Cl, and I'll write it as 2H. So what happened? This H and this Cl gets eliminated as HCl. In place of C, what goes? H goes. So you get what? CHCl3 chloroform. So on reduction of carbon tetrachloride with ion filings and water, you get chloroform. This chloroform which is produced is not pure and used mainly as a solvent. So chloroform produced from carbon tetrachloride is not pure. It is mainly used as a solvent. So pure chloroform is obtained by distilling chloral hydrate with concentrated sodium hydroxide. What is chloral hydrate? Chloral, I told you, trichloroacetaldehyde is Cl3CHO is called as chloral. Chloral hydrate means this. What happens, you see? So we can write as OH and you can 2OH. So I can write chloral hydrate. This chloral hydrate, when we react with sodium hydroxide, you get chloroform, sodium formate, and water. This is one of the one more method of preparing chloroform. Liquid. Chloroform is a sweet-smelling, colorless liquid. It is heavy liquid. Density is 1.485, and it boils at 61 degrees Celsius. It is practically insoluble in water, but dissolves in organic solvents such as alcohol and ether. It is non-inflammatory. Flames. So you have heard Beilstein's test in the laboratory. The detection of halogens. So if chlorine is present, when you dip the organic liquid and expose it to the flame, if you get a green flame, it indicates the presence of halogen. So that's called as Beilstein's test. When vapors are inhaled for sufficient time. When vapors are inhaled for sufficient time, it brings about temporary unconsciousness. Next, chemical property. Are you following, students? Am I fast or okay?
So, okay, sir.
Okay. Are you sure? You tell me
Yes,
if I'm
sir.
fast, you can stop me.
It's fine, sir. It's fine.
Fine. Chemical properties. Chemical properties under that the first reaction is oxidation. Chloroform is CH. The structure they were represented. Chloroform and oxidation in the presence of light and air. What happens is there's an intermediate compound. The oxygen bonds between this carbon and this oxygen. An unstable molecule. Now, this is an unstable molecule. What happens is this H and Cl gets eliminated as HCl. When this H and Cl gets eliminated as HCl, this double bond shifts between carbon and oxygen. Therefore, you get, sorry, this is chlorine, and you'll get a double bond. This is called as phosgene. It is a poisonous gas, phosgene. COCl2. This is the molecular representation, and they've given the structure here. So COCl2 is called as phosgene. See, it's written here. Phosgene is an extremely poisonous gas. To use chloroform as an anesthetic agent, it is necessary to prevent the above reaction. So when you're using chloroform as an anesthesia, you should prevent this chloroform undergoing reaction with light and air, forming phosgene, because this phosgene is extremely poisonous. The following two precautions are taken to store chloroform. The chloroform is not stored in an open container or a transparent container, because this chloroform can react with air and light to form phosgene. Therefore, how chloroform is stored? It is stored in dark blue or brown colored bottles, which are filled up to the brim. There should not be any space. If there is any space in the bottle, air will be there. That air will oxidize. That air will react with chloroform to form phosgene. So therefore, it has to be filled up to the brim. 1% ethanol is added. This retards the oxidation and converts phosgene formed into harmless ethyl carbonate. So 1% ethanol is added to chloroform. When you add 1% ethanol to chloroform, what happens? This phosgene which is formed reacts with ethanol to form ethyl carbonate. And this ethyl carbonate is harmless. Okay, so they can ask you how phosgene reacts with ethanol, or why phosgene is toxic, poisonous. They can ask you, and they can ask you simply, what is phosgene? What is phosgene? COCl2 is phosgene. How phosgene is prepared? Phosgene is prepared by the reaction or by the oxidation of chloroform in the presence of light and air. And this phosgene is highly poisonous gas. Next reaction is reduction. We have also. Now, reduction. Chloroform and reduction. Reduction is addition of hydrogen in the presence of zinc in HCl. Zinc. See, one of the hydrogen reacts with one of the chlorine to form HCl. In place of that chlorine, hydrogen goes. So you get CH2Cl2. It's called dichloromethane. Now, similarly, chloroform, which next reaction, chloroform, chlorination. This hydrogen as HCl. In place of this hydrogen, the other chlorine goes. Therefore, you get what? CCl4, carbon tetrachloride. So chloroform on chlorination, we will get carbon tetrachloride. Now, this is second chloroform. You can see chloroform, CHCl3 chloroform. When this chloroform is made to react with aqueous NaOH, NaCl gets eliminated. In place of NaCl, OH goes. I told you, if a carbon contains more than one OH, it's unstable. So when I say it's unstable, it has to lose water molecule. When it loses water molecule, you get CH, C, double bond O will be formed here, and OH. So actually, what is that you're getting? You get CH, C. It is here. There's only hydrogen here. So this carbon only, I've shown it here. It's nothing. Formic acid. This formic acid further will react with sodium hydroxide. What happens now? This OH and H gets eliminated as water. In place of H, Na goes. So I'll get H, C double bond O and ONA. It is called as So chloroform on hydrolysis with sodium hydroxide. Finally you get sodium formate. The intermediate compound is formic acid. Finally, the product what we get is sodium formate. Nitration. See, this is chloroform. When treated with nitric acid is HNO3. We can write it as HNO3 like this. What happens here is this OH as H2. In place of this H, you get NO2. So you get CNO2Cl3. It is called as chloropicrin. This chloropicrin is used as a tear gas. Tear gas, it causes tears in the eyes when this gas is exposed. Therefore, it is called as a tear gas. What is the chemical formula of chloropicrin? The chemical formula of chloropicrin is CNO2 and Cl3. Nitric acid. Next one, reaction with silver powder. Chloroform, we have written it like this, CH, Cl3. So we'll write Cl3 and CH. When this is heated with as a byproduct. When you get 6-AgCl as a byproduct, what's that you have? You have CH and you also have CH. So there will be a triple bond. Atoms are eliminated, triple bond. This is nothing but ethine. Ethine is commonly called as acetylene. It's called as acetylene. Followed?
Yes, sir.
Yes, sir.
Next, a lot of reactions we are going, you should be in a position to understand. Next is condensation reaction with acetone. Condensation reaction means it's similar to addition reaction. There won't be any product eliminated. That's called as condensation reaction. CH3, this is chloroform. This is ketone. It is ketone. Acetone, CH3CO, CH3. What happens now when this is in the presence of alkali? You get chloritone. You get chloritone. What is that chloritone? So you have this oxygen gets bonded to hydrogen. So therefore you get OH. You will get COH and Cl3. See? And now there will be a bond formed between this carbon. So you have CH3 and you have CH3. This is called as chloritone. So the IUPAC name they have given 1,1,1 trichloro 2-methyl 2-propanol. All right. So this is called as chloritone. Next, reaction with sodium ethoxide. Reaction with sodium ethoxide. Sodium alkoxide. When ethanol is reacted with sodium metal, when ethanol is reacted with sodium metal, what happens? The sodium metal will displace hydrogen. Therefore, you get C2H5ONA. This is called as sodium ethoxide. When chloroform is treated with sodium ethoxide, what happens? NaCl gets eliminated in place of the Cl, OC2H5. So you get ethyl orthoformate. This is called as ethyl orthoformate. Now, coming to the next set of reactions, Riemann-Tiemann reaction, carbylamine reaction. We'll finish. Riemann-Tiemann reaction. In phenols chapter, we will learn the mechanism of the Riemann-Tiemann reaction. Now, when phenol is treated with chloroform and sodium hydroxide, like this, a benzaldehyde, you get OH and CHO. This is called as salicylic aldehyde. Salicyl aldehyde. So I'll teach you the mechanism in the chapter alcohols and phenols. We have this in the same chapter, alcohol, not in the same chapter, next chapter, alcohols, phenols, ethers we have. In that chapter, we will learn the mechanism of the Riemann-Tiemann reaction. So Riemann-Tiemann reaction is of two sets. One is phenol, chloroform, sodium hydroxide. The other one also you should remember, it is phenol, carbon. Since we are talking about chloroform, we are not mentioned here, carbon tetrachloride and sodium hydroxide. So you will get a product called a salicylic acid. You will get here it's an aldehyde group. Here it will be an acid group, salicylic acid. So phenol with carbon tetrachloride and alkali, you will get salicylic acid. Phenol with chloroform and sodium hydroxide, you will get salicylic aldehyde. Next, what we have is carbylamine reaction. Primary amines. Now, for an example, if you take methylamine, this methylamine, When heated with chlor, what happens? Now this gets eliminated as 3Ks here. And you can see 2 hydrogen, third hydrogen, and you have 3 OH groups here. These 3 OH groups and this 3 hydrogen gets eliminated as 3H2O. And what is left out now? You have CH3, you have N, and you have this carbon. So it's called as methyl isocyanide. So this methyl isocyanide which is formed is called as carbyl amine. This carbyl amine is highly poisonous. Now this carbyl amine is answered only by primary amines, whether it's an aliphatic primary amine or aromatic primary amine. If you use aniline also, this reaction will take place. So in case of aniline, what will be the product you will get? You will get a product like this, 3KOH. What will be the product you will get? The product you will get is, you get a benzene ring and NC. You will get NC. All right. Now, what are the uses of chloroform? It is used as a solvent for fats, waxes, rubber, resins, iodine. It is used for the preparation of chloritone, a drug, chloropicrin, an insecticide. It is used in the laboratory for the test of primary amines, iodides, and bromides. It is used as anesthetic, but due to the harmful effect, it is not used nowadays. It may be used to prevent petrifaction of organic materials, that is, preservation of anatomical species. Test for chloroform, it gives isocyanate test, carbylamine test. It forms silver mirror with tolerance reagent. Pure chloroform does not give white precipitate with silver nitrate. So pure chloroform will not give white precipitate with silver nitrite. So the next is iodoform. The next concept is iodoform. We will learn iodoform, and so much is there, carbon tetrachloride, and also we will learn haloarenes in there.
Sir, are you there?
Hello, ma'am. Hello, Ajay. What
Yes,
happened?
sir.
There were some
Sir,
issues
yes,
with
sir.
the network, I believe. Yeah.
Yes, sir.
Anyways, I think we're done with class today. We'll stop. All right. We'll meet tomorrow.
Yes, sir.
Ma'am, I'll stop.
Thank you, sir.
Yeah, bye.
Thank you, sir.
Bye, ma'am. Ma'am, bye.
Thank you, sir.